So we're going to talk about demonstrating 3DMC squared. We've talked a lot about 3DMC squared as a revolutionary product, but it's one of those things where you could talk the words, but realistically the best way to demonstrate it is to put the guy in the seat of the machine and let him run it. Once you've done that, you've got the deal, because it's a jaw-dropping system. The statement is, I've got to have one of these. That's what's going to happen, but you got to get him in the seat. So what we're going to talk about is actually how to go through that demo and do a good demonstration of the product. First of all, talking about how 3DMC squared works. As we know, our traditional GPS-based systems are well-working systems. You can cut very, very good grade with those. However, what happens with conventional 3D systems is, due to the nature of GPS, the update rate going over ground, we have to commonly slow the machine down to cut nice, smooth grade. So those operating speeds are common, typical with the speeds that the operator may normally grade at. However, there are limitations to GPS. The first limitation we want to talk about actually is the dozer itself. Specifically, smaller dozers are even harder to control than even big dozers. And this, of course, is done manually as well as with automation. Small little dozers like this one here, we've got a short coupled machine. We've got a cutting edge that's out in front of the dozer. So the tracks, the dozer ends up riding on top of the machine it's working on. When you're in a cut situation, the dozer itself tends to ride up and so forth over the cutting edge, which makes controlling the cutting edge out in front a very difficult thing to do. So first of all, we've got the nature of the dozer itself to deal with. And then, of course, secondly, when it comes to GPS control, again, even at a 10 hertz update with GPS, the dozer, when we're traveling, has moved several inches before we get a new update position from GPS. So how do we solve that? We solve that by doing something totally different, totally revolutionary, which is 3DMC squared. So with 3DMC squared, we're going to take a totally different approach. We're going to use the 3DMC squared sensor, which has 3 inertial sensors that measure position, 3 gyroscopes, electronic gyroscopes that are measuring the position of the cutting edge, and other sensors. What we've got then is a sensor that at a rate of 100 times a second knows the exact position of the cutting edge. So what we do is we simply use that sensor to control the machine. We still rely on GPS. However, GPS is simply giving an update position to this sensor. So GPS realistically is not controlling the machine. The 3DMC squared sensor is actually controlling the cutting edge of the machine with the update positions coming from GPS for control. Okay, so we've talked about the 3DMC squared inertial sensor giving us instantaneous measurement position. The other part of 3DMC squared that it really is truly revolutionary is the control algorithms. One of the things we talked about the dozer, the hard part about a dozer is the nature of the dozer itself. So the other piece of 3DMC squared we do is actually measure this machine. We'll measure the track length, we'll measure the distance from the tracks to the cutting edge. We're actually creating a model of what this particular dozer looks like. Then what we can do is use sophisticated control algorithms that model the machine as well as the instantaneous position measurement from 3DMC squared to get the results we're getting, which is, again, truly revolutionary. So now it comes to demonstrating the product. Again, what we've seen is a revolutionary product with 3DMC squared, but how we demonstrate it. If you've got a guy in the seat of a machine, versus you put it on your job site or you bring them to a road show, a great way to demonstrate 3DMC is to show the performance, that the aspects we're looking at are the speed of the machine. We want to show how fast it can cut, but secondly, it also is twice as accurate. Contractors are totally impressed when you're running at speeds, but also seeing the accuracy of how it is matching from pass to pass as they're cutting grade. And then, of course, when we turn the machine, typical with our traditional slope sensors, we do get some vial slosh. With 3DMC squared, we can demonstrate how we can actually make curves and turns and actually have a very, very stable situation. Now, the other thing that comes to play is that, of course, most job sites are not smooth, flat, planar surfaces that we're grading for a construction site. So we do need to be able to demonstrate the product actually cutting something that's not just a nice, smooth surface. So we highly suggest that you actually create a small surface with some variations in it. And then actually what we can do is switch to automatic control and actually show how 3DMC squared will show that cutting edge controlling through a non-planar surface, cutting nice, smooth grade. The last aspect, of course, is when that machine lands on the job site, even if you are trying to create a smooth surface, that site isn't smooth. The reason you've got a dozer there is because that existing natural ground is rough and bumpy and so forth. So how really does 3DMC² perform when you're trying to cut a smooth surface, but the machine itself is riding on very undulating surfaces? And that is a great demo right there. You can do that a couple of ways. If you have created a non-planar surface, then what you can do is cut that back off again to show how you can go over a rough surface, make it nice and smooth. If you don't have that surface, simply take a smooth surface and manually dig some moguls, tear the thing apart so that you can see some variations, and then take 3DMC², and that is when the contractor really sees how the system works.